from Algebra 1 to Chapter 9. Today is 9.1. So I'm working from two papers. One is a notes paper with the problems that are behind me from 9.1. The other is a vocabulary paper that says fill in day by day by watching videos, which is a nice place to organize all the important information into one place. So I'll start off, I guess, on the organize in one place. Number one, this chapter 9 is about a thing called linear equations, L-I-N-E-A-R equations. Number two, while we get the chapter warmed up, those are just equations that if we graph them, we get a line. And you don't really know what that means yet because you haven't done a lot of graphing or barely any graphing in your lifetime. But we're going to do some graphing in this chapter. I had advertised about 2 weeks ago that you were going to need graph paper when we got to chapter 9. Today, if you own graph paper, that's helpful. If you're still on quarantine and you're stuck at home, maybe you could print it out from the internet, or if you can't do that, then maybe you could just kind of do your best to kind of draw your own graph paper. Like to my left, I drew a bunch of sort of messy looking graph paper on my board because I don't have graph paper to put on my blackboard. Number 3 is where we come in on the board here with the notes. An ordered pair looks like this. We're going to have in parentheses, separated by a comma, two numbers. The first number is called the x-coordinate, and the second number is called the y-coordinate. So over here I have 1, 2, 3, 4, 5, 6, 7, 8 ordered pairs of numbers. The word order means that the order matters. If I tell you 2, 3 is where I'm headed, that's different than if I had the 3, 2 on the graph paper grid here in a minute. Here I have 3 more ordered pairs. Okay, so we're going to be dealing with a lot of ordered pairs in this chapter. The x-coordinate, the first number in the pair, is going to send you right on our graph if it's positive, or left if your number is a negative. And if that seems familiar, it's because we did do this in 7th grade. The y-coordinate will send you up if you're positive, or it'll send you down if that number is a negative on a thing called a coordinate system. So number 4 to 8 on the take some notes paper draws you a coordinate system. So here is a drawing of a coordinate system. There's a thing called the x-axis that runs straight across, left and right. Since the x-axis runs horizontally, left and right, that's why the x-coordinate is sending you either left or right, just like the number line does. Left is negative, right is positive. The y-axis runs vertically, straight up and down, so the y-coordinate is going to send you either up or down, kind of like a thermometer. Up would be positive, down would be negative. The point where those two axes cross, and the plural of axis is axes, so we have 2 axes, when one axis crosses another axis. That point where they cross is called the origin. And when you do that crossing, you separated the world on the board here into 4 areas. This is called, each of these 4 areas is called a quadrant. This is quadrant number 1. I think they made it quadrant 1 because it's where everything is positive. Because we're right and up. If all the numbers are positive, we'd be in quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. So you could copy that on your paper, and then we could basically set this paper aside until a future video, because there's nothing else on there today. Your job today, primarily, is going to be to plot these points, these ordered pairs, on a coordinate system. And that'll be a necessary skill as we build through our chapter. If you can't handle this today, it's going to cause us trouble all chapter. We need to be good at this. Okay, so here's my first one. The first number is, again, the x-coordinate. That's going to send me either right or left. So a positive 2, I would start here at the origin, and I'd go right 2 squares. The y-coordinate is the second number. That's going to send me up or down from where I'm now sitting, which was right here. I moved right 2. And now I'm going to head up 3, and I'd be right here at the corner of the square. And I could stick an A next to that just to use as the identifier for who's going to be who on this graph. This has a negative number, so it's not going to be in quadrant 1. A negative 3 would send me left 3. Then the positive 4 is up 4. And I'd be right at the corner of the square. I could label that with a B. If I go positive 1, negative 2, I'd go right 1 for the positive 1, because the first number is always right or left. Then down 2 for the negative 2, and there's C. For D, if we're all negatives, we're going to be in a new quadrant we've not been in before, in quadrant 3. But negative 3 would go left 3, negative 2 would go down 2, and that would be a D. If we get zeros involved, life gets easier. Then you only have to make one move. Okay? This first number is right or left, so we have positive 1 to the right. And the 0 for the y means just don't do anything else. Just go right 1, and there's my E. This is telling you don't go right or left, but for the 4, go up 4. So there is the F. This negative 2 is sending you left 2, and the 0 lets you just do just that and stay and stop. This tells you don't go right or left, but go down 3. If I just go down 3, always starting from the origin, go down 3 lines worth, and I'd be at H. If I wanted to do the coordinate of the origin, you might be able to successfully guess the origin's coordinates would just be 0, 0, or just because we're there at the start. In the homework, they have 1 or 2 that they involve halves in them. So if I decided to do, let's say I make this 4 1/2, I'd still go the left 3. But when I would try to go up 4 1/2 squares, 1, 2, 3, 4 is here, 5 is there. If I were going to go 4 1/2, I would just need to go exactly halfway in between the 4 and the 5 lines. We're not at a corner of a square anymore, we're just kind of like floating out in the middle of space. They don't do any weirder fractions than halves, but I think the homework does a couple halves. You're good at about half the homework now. We'll be working page 372. From 1 to 16, you could draw yourself one coordinate system, ideally on graph paper if you own it, and then just scatter all the letters all in the right spots. Put a dot for the location of where every letter would go, and then just put a letter next to it so we know who's who. Then starting on 17 to 20, they'll do a different game. They'll do some questions like this. They'll ask you if a certain ordered pair is a solution of a certain equation. Remember, the first number represents x, the second number represents y. And as always, if you want to see if you have a right solution, you just plug those numbers in. So the 3 would go in where x is, 2 times 3 is 6. The 2 goes in where y is, 3 times 2, also 6. 6 plus 6 is equal to 12. If everything works out, you just say yes. If we would try to put this in, 6 goes in for x, 2 times 6 is 12. Put the 0 in for y, 3 times 0 is 0. That does add up to equal 12. So that's another yes. As long as things add up in this problem to make 12, we just keep saying yes. One more try. 4 is the x, 1 is the y. If 4 goes in for x, 2 times 4 is 8. If 1 goes in for y, 3 times 1 is 3. 8 plus 3 makes 11, so this time no, because the goal was to make 12. That should take you, okay, from now 17 to 20 doing problems like that. They'll give you a couple answers and they just want to know which one works. So once you find the one that works, you're good. If the first one works, you don't have to try the second one. They're just asking you which one works. 21 to 28, they're going to do a different game. 21 would need its own coordinate system, 22 its own coordinate system, 23, 24, each problem will need its own coordinate system. What they're going to have you do on these from 21 to 28 is you're going to have 3 points to plot. The way we were here, we had about 8 or 9 plotted over there. They'll give you 3, and then they want you to play connect the dots and make a triangle out of them. Okay, but that's going to get way crowded. You need to do 21 in its own space, 22 in its own space, 23 in its own space, to avoid the overcrowding. 1 to 16 can all go on the same coordinate system, no problem, because you're just doing dots and you're not connecting the dots. But on 21, where they ask you to connect the dots, 21, 22, 23, 24 each gets its own space, and that'll take you up to 28. Anything there that you didn't understand, give me an email, and we'll work it out. See you later.